Rudolph as
Sure.
well.
Yes. Hi, my name is John Rudolph. I'm with GEI Consultants, and we are under contract with LESJWA to perform the TMDL monitoring on both Canyon Lake and Lake Elsinore as well, the nutrient TMDL monitoring, that is. So thank you for inviting me. I wanted to give you a brief update on some things going on at Canyon Lake and some of the future plans that we have to combat the golden algae and the current situation we've got going on there. So let me move forward with this. There we go. Okay, so just quickly give you kind of an idea of where we're headed with the presentation today. It'll be in two different portions. I'll be giving the first portion, which will be the update on the golden algae. And then Steve Wolosoff, who I believe is online, will be, can you confirm that you're online, Steve?
Yes, I'm here.
Okay,
Can
great.
you hear me?
Yep, I can hear you.
Okay, great.
Okay, Steve will be giving the second portion of the presentation, which deals with the in-lake screening alternatives that we're looking at for nutrient control and just moving forward with some more treatment controls for Canyon Lake in general. But I'll start off with the golden algae part. So just to kind of preview a little bit more, it's really just an informational update today. I'm not asking for any sort of action or decision to be made. We're just here to give you an update of what's going on there and how we're moving through various steps to kind of combat the golden algae and what's been going on at the lake there. And it's just an overview of current conditions as well as some potential strategies we have moving forward to deal with that situation. And anything that we do in the future, we'll be coming back to you guys to make any decisions at that point. And so regarding the alum, so all of you, I'm sure you're all aware, alum treatments do happen on Canyon Lake. It has historically been done twice a year in the spring and the fall. That is done historically, it's always been done on a criteria-based basis. And so we have, which I'll walk through here in a minute, there's a couple of things that either trigger to move forward with an alum application or to postpone it. And so these are based on water quality thresholds, specifically phosphorus, and also more recently, the algae that we're dealing with at Canyon Lake. So we'll go through that here in a minute about what those steps are and the various triggers. This year we have decided to postpone, which I guess would have answered the question of the woman who was just here. But we have decided to postpone this upcoming one, and I'll step through that with you here in a minute, because those criteria were not met regarding the triggers that we use for the alum application in the spring. And so this is the decision tree. This is the one that we've used historically. It goes back almost to the beginning of the program about what do we do, and like I mentioned, two different treatments, one in the spring, one in the fall. What do we do in the springtime? So Canyon Lake TMDL monitoring happens on a bi-monthly basis. So February, April, June, and so forth on down the line, 6 times a year. And so we try to target for our alum applications in the springtime after many of the larger storms have come through, which introduce phosphorus to the lake, but before the water starts to really warm up enough to really instigate an algae bloom. Once the water starts to warm up, that's typically when you see cyanobacterial blooms happening in the lake. And so we want to kind of hit that happy medium in between the two. So during this February event, we do collect phosphorus, total phosphorus, that's what the TP stands for there on the slide, total phosphorus concentration. For our February application, if the total phosphorus concentration at any one of the locations, there's 4 which we monitor in the lake, is above 0.1, which is a TMDL limit, water quality basin objective, we go ahead and apply alum. If it doesn't, we forego the spring application and move on to the fall. The fall application typically happens in the October timeframe, late September, October timeframe. So we do have a monitoring event on the lake in August. We go through that same thing, but this time we're looking specifically at East Bay. We've had a long time. There hasn't been, don't typically get storms over the summertime. So we look at specific East Bay, which tends to have higher biomass, algae biomass concentrations than does the main bay. Also, the main bay tends to get more stratified. It's deeper. You get stratification where there's not a whole lot of mixing between the lower levels and the upper levels. So when we're looking at the phosphorus concentrations in August, we're specifically looking at those in the East Bay. If any of those are above 0.1, then we move forward with the application in the East Bay and the main bay. If there's nothing going on in East Bay, concentrations are low, we just go forth with the one in the main bay. And that's specifically to combat the stratification which happens in the main bay. If you're familiar how that works, sometimes when there's a hypolimia, there's not mixing between the top and the bottom layers. You get a phosphorus buildup in that lower level. We want to combat that because what happens in the fall is the lake flips. the stratification goes away, that really high nutrient water in the bottom comes up to the top, you can have an algae bloom. So in order to mitigate that, we try to apply the alum before it goes into that mixing process. So that's kind of the strategy we've used historically. It's all based on nutrient levels in the main bay and the east bay.
Yes, please. Just a quick question for you. I know that the Property Owners Association has been doing testing themselves. Are you aware of that?
Yes, we were part of that.
Okay.
We are part of that.
So you guys are in communication on those tests, so we're not duplicating efforts. We're in communication on both sides. And
yes, but we're under contract right now with the POA. Eric Kazikoff there to conduct golden algae sampling as well as water quality parameters in the lake.
Perfect.
Every couple of weeks at this point.
Okay. Thank you for that.
Yep. And so, given what I just said, historically we've used the phosphorus concentration in the water to decide if we're going to apply alum or not. These are the February total phosphorus concentrations from this last February 2026. And as you see, those are the 4 sites we monitor, CL7 through CL10. Sites 7 and 8 are in the main basin, sites 9 and 10 are in the east basin. Total phosphorus, and then orthophosphorus is just the dissolved fraction of phosphorus. So we're looking at the total column there. It's what we use for our criteria. You'll see that 3 of the 4 sites were below that 0.1 criteria or at the 0.1 criteria. Site 9, which is in East Bay, was a little bit above it. Okay, historically what we would have decided, well, okay, we have a site that's high, we're going to move forward with the alum application. However, we have a confounding factor this time around. Golden algae, which I'll get into here in a little bit, describe more about that. We had a golden algae bloom starting last April. And so we decided, because of this other complicating factor, and what I'll talk about a little bit, is it appears as if when you get drastic reductions in nutrient concentrations in the lake, this triggers a toxic event with golden algae. So I'll talk a little bit more of that here in a little bit, but this weighed into our decision because although we did have one site that was high in alum, we didn't want to trigger any sort of toxic event by drastically reducing the phosphorus. The alum is doing its job. That's what it's supposed to do. If you look long-term across the total phosphorus concentrations in Canyon Lake, it's gone down drastically since we started the alum application, which was the purpose all along. But now we have this other confounding factor of golden algae get into the lake and makes the decision process a little bit more complex. So given that we saw 3 of the 4 locations below our target for phosphorus, also golden algae is now in the lake, we decided to forego the alum application for this spring. So what do we know? And then what are we trying to find out? We know that golden algae is at fairly high concentrations in the lake. I'll go through in a minute. Started almost a year to the day. Last year, April of 2025 is when we first saw golden algae show up in the lake. It's currently at a pretty high level. We're talking about 13,000 cells per milliliter in multiple locations, especially in the East Bay. We've seen high fish mortality in the lake last spring. We saw lots of different fish, all kinds, shad, bass, carp, catfish, bluegill, crappie, all different shapes and sizes of fish, multiple age classes, classic golden algae fish mortality event. What we're also seeing is from samples we're gathering in the lake. Now, step back a little bit, the toxin that golden algae produces is called promethium. There's currently no way to quantitatively measure this in a laboratory. It's not like I can go measure, a nutrient concentration in the lake and I know, okay, it's 0.1 milligrams per liter. There's no quantitative measure currently, methodology to measure promethium in water. The best way currently to know if you've got a golden algae problem that's giving off toxins is to look at the cell count in the lake and do what's called a minotoxicity test. And I'll describe what that is here in a minute, where you expose little small minnows in a laboratory setting to the water and see if they live or die. Okay, toxicity. So we have been seeing that. We've been collecting golden algae samples of the lake. We've been taking samples on a biweekly basis since about last fall, looking at the toxicity. And I'll show you some of that data here in a little bit. And we have seen some high toxicity in the lab as well from these samples. The other thing that we know is the conditions in the lake last spring and even to current are different than they've been in prior years. We're seeing higher pH levels in both basins. We're seeing higher connectivity or salinity, same thing in the lake in both basins. The East Bay is typically a little bit higher than is the main basin. And as I mentioned, we've seen this connection between the amount of alum we're putting in the lake, or when we apply alum to the lake, and the phosphorus concentration in the lake. We've seen this drastic decline in phosphorus over time, as well as overall algal biomass in the lake has gone down over time in Canyon Lake because of the alum applications. Now, what we're currently trying to evaluate is now that golden algae is introduced to the equation, what do we need to find out? And so currently, we've done a lot of research on this, looking at literature values and even doing some experimentation ourselves, which I'll show you here in a little bit. What's the role of nutrients in the golden algae growth and or toxicity? Phosphorus, nitrogen. What's the role of TDS? TDS is total dissolved solids, or conductivity or salinity. It's all a measure of the same thing, salinity of the water. How does that interact with nutrients? How does that affect golden algae growth and toxicity? And then also temperature and pH and other factors. There's lots of different factors that could interact and cause a golden algae bloom and or toxic event. So those are some of the things we're trying to find out through some experimentation. I'll point to a little pilot experiment we did currently back in January, and then what we need to do moving forward to find out what are the real triggers, what are the real things that we can use to help mitigate this golden algae that's in Canyon Lake. So let me take a step back, take you back to last April 2025. It was over the weekend, April 19th. I got a call from, forget who it was. It might have been you, Rick, actually. There's some fish dying in Canyon Lake, some reports of fish dying in Canyon Lake. So we got this report on April 19th. I was out on the lake April 23rd, just 4 days later is when we got a call. Started in the East Bay. As I mentioned, we're seeing all kinds of fish showing up, different size classes. This wasn't just small fish. This was very, very large fish as well. And within 2 weeks, it wasn't just isolated to the main or to the East Basin. It had spread to the main basin. We were the same types of die-off we were seeing in the main basin as well. So again, we were mobilized to investigate this. We looked at things such as water quality. What are some of the common things that might cause a fish kill? Low dissolved oxygen is one of them. So we went out, took a look at the water quality at Canyon Lake. Sure enough, the dissolved oxygen is high. That's not a problem. We took some algae samples to see what kind of species we might be dealing with. We took some water samples from the lake. Again, like I mentioned, doing this toxicity test in the lab. It's called a bioassay. Some other things that might come up, okay, is aluminum an issue? We've been applying alum for years. Lo and behold, alum was very low. Aluminum was low. So that's well below anything that could cause a toxic event. Same thing with ammonia. Same thing with sulfide. Other typical toxic compounds you might see in a lake that would cause this kind of acute toxicity. All of them were below any kind of threshold, well below a threshold that might cause toxicity. When we get the results back from the algal speciation, very high concentrations of golden algae. The fish in the lab that we took for bioassay died within just a few minutes of us starting the toxicity test. It's it's usually a 4-day test. They died within, say the first hour of the test. So we confirmed that it was golden algae that was causing the issue, not only just by these laboratory things, but just observationally. We're seeing, as I mentioned, lots of different types of fish, lots of different size classes of fish. It wasn't just a passing kind of temporary die-off of, say, shad or something, which are typically really sensitive to really small changes in water quality. The other thing we're seeing is I have a picture up here. When you have a golden algae toxic event, you see hyper red gills, hyper red fins on the fish because of this. What it does is it actually suffocates the fish. It interferes with the oxygen transport across the gill, and the fish actually suffocates. So a lot of times you'll see fish kind of gulping at the surface. Your DO is really high, but they just can't access it because this toxin affects the gill membrane. And so we were able to confirm that it was golden algae starting in about August or April of last year. And just to kind of show you a little bit of progression in photo form, we were out there on a monthly basis, in fact, every other week back then. And to show you how the color of the water changed, you can see why they call it golden algae. You can see how the color of the water changed based on the density of the cell count that we got. The highest count that we got was actually right around that June 11th sample. I think it was just right after that, actually. It was the highest count we got, which is up about 29,000 cells per mil. And then as the water started to warm up, as we got closer and closer to summer, we started to see the algae disappear. By the time we got to July 31st, it was gone. And this was without any kind of treatment at all. This was just seeing what happened over time. It started to go away. And this is a known thing. Golden algae prefer colder water. Usually you see blooms. It's very, very big in the Midwest, North Texas, Oklahoma, Arizona. It shows up in the wintertime. This is the opposite of every other type of algae, really. Usually the summertime is when you see the blooms, right? These guys bloom in December, January, February. They also prefer more saline water. So the higher the conductivity, the higher the TDS, the higher the salinity, you'll see more and more of these. So as the water warmed up, they don't like it. It got to be about 26, 27 degrees. We saw the population crash down to 0. And I'll show you a slide here that kind of shows that in a little bit more detail. So because this algae bloom happened, we were set off on a couple of different tasks. One of them was to develop a plan. Okay, what are we going to do from here? We've never seen golden algae in this lake before. How do we handle it? What do we need to do? So we developed a couple of documents, a couple of plans around this. One of them was just to do an overall review of what are some algae management strategies for Canyon Lake specifically, looking at short-term treatments, mid-term treatments, long-term strategies, kind of a document that laid it all out. We gave that to, we were working in association with EVMWD as well as the POA in this case. We also updated the EVMWD, we call it the APAP, which is the Aquatic Pesticide Application Plan. This is a document that's required if you're going to apply an algicide to a lake. And so at the time, the APAP, or the document that EVMWD already had, was very specific to right around the drinking water intake, right near the dam. It wasn't applicable to the whole lake, so we were able to update that plan. So if we did have to move forward with an algicide treatment, we would be able to do so because we had this plan already in place. And so we updated that document. Lo and behold, after many discussions with EVMWD, the POA, SAPA, and just going through our own scientists, we decided we were continuing to see, well, let me back up a little bit. The algae went away across the summer, started to come back. In September, we saw just tiny numbers of it. By the time we got to October, the numbers were starting to ramp up again because the water was cooling. Okay. And so because we were seeing this, we didn't want the same thing again to happen as we saw in the spring. We start to see another major fish die off. So at this point, it was a group decision. We're going to go ahead and apply an algicide application. This happened in the week of November 3rd. And we saw a drastic decrease in golden algae. In fact, many algae types, obviously. This doesn't discriminate between different algae types. So this algicide happened the week of November 3rd. Then we were able to develop a algae monitoring response plan specific to golden algae. Okay, what do we do when it gets to this level? What do we do when it gets to this level? And a third level, we had a 3-tier document kind of described. This is still in process. It's a draft that's currently underway. We've been going back and forth with EVMWD on this and kind of trying to work it into a more overall plan about what to do about not just golden algae, but just algae in general with Canyon Lake. And finally, we've been doing continued bi-weekly monitoring for golden algae. I'll show you a graph here. I think it might even be the next slide of just looking at golden algae concentration over time, water quality over time every 2 weeks, and also the fathead minnow toxicity and how that reacted to golden algae density in the lake. Well, one more slide maybe. Just wanted to point out the differences that we're seeing here. And so this is starting in, we had the, as I mentioned, the algicide application happened in November. We saw a drastic decrease in golden algae. The recovery of the 2 basins was quite different. Now we saw golden algae start to reappear in Canyon Lake, or I'm sorry, in East Bay of Canyon Lake within about a month and a half of the algicide application. Now we always knew, the algicide application is a short-term fix. It's a Band-Aid really. It's not gonna solve your problem. It's not a one-stop shop. You apply your algicide and you're done forever. We knew going in, we wanted to mitigate any sort of toxic event happening, knock down the algae. There's a potential it could come back. Okay, so moving in, we knew that going in. And sure enough, we started to see the golden algae reappear in the East Basin about a month and a half after application. The main basin, it really never came back until recently. In fact, sample from last week was really the first time that we saw golden algae starting to reappear in the main basin. And so why is this? Why are we seeing the difference between these 2 basins? We had concentrations of up to about 19,000 cells per mil in the East Basin after the application. The highest we saw in the main basin was about 50 cells per mil up until about last week where we saw a few thousand cells. And we're starting to see some fish die off now occurring in the main basin as well. So it appears out as if it spread back to the main basin again. But we're also seeing differences. We're seeing different pHs between the main and East Basin, different connectivities. Again, much higher concentrations of salts in the East Basin than in the main basin. Temperature differences, it's much shallower in the East Basin, much deeper stratified in the main basin. Also, sediment disturbance could potentially be an issue. This is something we want to investigate. East Basin is much shallower. It gets wind-driven turbidity just because of the water, mixing more easily. The bottom is closer to the surface, obviously. So you get sediment resuspension. You have boats going back and forth, which could potentially stir up the sediment. And what we do know about golden algae is it produces these very resilient spores that can actually even resist drying and then come back and repopulate a lake. And so what happens is these spores As the algae die, one of the reproductive methods is to produce these spores that are basically hardened kind of cyst-like things that fall to the bottom, that when conditions are right, they can blossom and start a new bloom. As they get resuspended, this can kind of exacerbate that process potentially. So that's one of the things we want to try to find out. It's one of those unknown factors about the East Bay. Why are we seeing this continual cycle in the East Bay now over the last year? Here's the graph I was speaking of a minute ago. So over on the left, you see those are the fathead minnows, the minnows I was talking about. There's an adult on the top. The ones we're actually testing are the little larvae. They're about 24 hours old. This little picture on the bottom you see there. And what I'm showing you on the graph here is golden algae density on the y-axis. Across the bottom are the dates that we've collected golden algae samples up through March 11th. The bars represent the golden algae density, with blue being the main basin, orange being the east basin. The little dots that you see, those are the fathead minnow toxicity test, which is the secondary y-axis on the right. Survival of the minnows. Blue dots being main basin, orange dots being the east basin samples. We collected at site 8 and site 10 consistently over time. So site 10 is the furthest east in the east basin. Site 8 is kind of a little bit north in the main basin. What you'll notice is when the bar goes up, the dot goes down. And so what that's showing you is we increase every time the golden algae density goes up, the fathead minnow toxicity goes up as well, less survival. In fact, in many cases, you're seeing those orange dots, which is east basin at the very bottom, which means we've got 0% survival in those tests. In the main basin, the ND represents a non-detect. There was a sample, we didn't find any golden algae at all. And you'll see the dots for the blue are very high. Now, if I had plotted the most recent sample just from last week, there would have been a blue dot down at the bottom again. But again, we did see an increase of about, I think it was right around 2,800 cells per mil showing up in the main basin. And so uptick in golden algae, increase in toxicity there as well. And we're seeing some fish dying in the lake as well. Now, this is just kind of a summary of that toxicity data. Again, looking at fathead minnow survival on the y-axis this time and golden algae density across the bottom. And what you notice is there appears to be a real threshold there. Right when you hit somewhere around 4,000 to 5,000 cells per mil is where we're seeing the toxicity. When you're below that, we're not really seeing much in the way of toxicity. So that appears to be a threshold for Canyon Lake. Now, this can be different in different lakes based on water chemistry. And that's one of the things we want to find out is what's the real driver of the toxicity and the cell density in Canyon Lake, which appears to have a little bit different water chemistry than does some other lakes in Southern California, even those we're seeing in the Midwest. What's really causing that drop off here? Why are we seeing at that specific cell density? Because I've talked with other professors. We're actually working with Dr. Dave Karen from USC, who's one of the foremost algal experts in California. And he said, he's seen toxicity down to less than 1,000 cells per mil in some lakes. Why are those algae producing higher levels of toxin, whereas other lakes have a much higher cell density, but you're not seeing toxicity, and vice versa? So we're not real sure, and we're trying to figure that out. That's one of the reasons I'll talk about here in a little bit, some of the experimentation we want to do to find out what's the driver of this in Canyon Lake specifically, and how can we go about mitigating that. So some of the kind of early things we did is to look at water chemistry in Canyon Lake. We looked at pH, we looked at TDS, which we know are some of the drivers related to either golden algae density and or toxicity. It appears as if there's a relationship between pH and golden algae density. And now it's not a strong relationship. You can see there's kind of a lot of data scattered across a large area, but there is a direct relationship between the golden algae density and an increasing pH. Now, whether this is caused by the golden algae or the golden algae is reacting to it, that's one of the things we're trying to find out, because we do know that sometimes increased algal biomass, you do see increases in pH as well. Now, one of the things we did see a pretty good relationship with is TDS and golden algae density. TDS, again, a measure of salinity of the lake. Pretty good relationship there, although you do see some scatter, but a much better relationship than we're seeing with pH or other factors. As the total dissolved solids goes up, we're also seeing an increase in the density of the golden algae. And this is a known thing. As I mentioned earlier, they prefer more saline waters, say up to about 5-6 parts per thousand. Seawater's at about 35 parts per thousand, so we're still well on the lower end of the scale. But Canyon Lake is very, very low. In fact, we're seeing levels of golden algae at much higher levels than we've seen really any other lake I've seen in the literature as far as salinity goes. We're on the very far low end of the spectrum for salinity and still seeing golden algae. I'll show you a little graph about that in a minute. We pulled up a couple of studies that really point this out. Oh, here it is, actually. So we looked up a couple of studies. Okay, what are we seeing across the scientific spectrum as far as growth of golden algae and temperature and salinity as well. So what you'll see on the graph that's on the left-hand side of there, P. parvum, that's just the scientific name for golden algae. You see the growth rate curve at various salinities. That's what 0.5, 1, 2, 4, and so forth. Those are the salinity of the sample. That's in parts per thousand, and various temperatures. The star is where Canyon Lake is at when we first saw golden algae show up in the lake. So you'll see it's very far down in the on the graph on the left. It's at the very lowest salinity that we're seeing and a much lower growth rate as far as the literature shows us than any of the other salinities or lakes that we're seeing out there. This is a study that was done on multiple lakes over time and some lab experience as well. Now, the one on the right-hand side, there's actually two different species of golden algae here. The one that we're seeing in Canyon Lake is actually represented at the bottom, P. parvum. But what you see, again, the star that we're seeing there, it's at the very far left side of the curve, very low salinity compared to what we're seeing in the literature. And also temperature-wise, same thing. And so for whatever reason, whether this is a specific strain of golden algae or the specific water chemistry within Canyon Lake, we're seeing this showing up at a much lower salinity and has a wider temperature tolerance than we're seeing with other studies that are out there in the literature. Now, one of the other complicating factors we're trying to deal with, and this kind of comes back to the alum application, is what's the relationship between phosphorus, nutrients in the lake, and golden algae? What you see on this graph, this is all data gathered from Canyon Lake, phosphorus concentrations over the last few sampling events we've had, and the golden algae of those same samples. And what you'll see is as the phosphorus goes up, the golden algae goes down. And so this is something we've actually seen in the literature. It appears as if higher concentrations of nutrients tend to show a reduced growth of golden algae and a lower toxicity level of golden algae. So this, once again, puts us in a little bit of a conundrum about what to do with the alum applications. So, in Canyon Lake? Yes, in Canyon Lake. It's the first instance I know, even looking back in the literature about Canyon Lake. I mean, it has happened in Lake Elsinore, happened in 2019. Very short time window, though, only about a month and a half. Large fish die off. Yeah, Bob, you probably know, right? I think they removed like 200 tons of carp or something like that from the lake. And it went away on its own and has never come back. And so a bit of a mystery there as well.
Well, do you have a suspicion of what the introduction came from? I mean, is it coming off of a boat that went to another lake perhaps and had something carrying on it? Or is it somebody throwing something in the water? I mean, where's the, yeah.
So,
I mean, seriously, where's the introduction, or where do you think the introduction came?
Yeah, I can't really pinpoint to anything specifically, but I do have a couple of theories. We do know that there was a golden algae bloom in Menifee Lakes back in 2014. And then more recently, it came back in 2022, from what I understand. Now, the golden algae we saw here, 2025, a few years later, it's potentially could have washed down from Menifee Lakes into Canyon Lake at that point. Maybe incubated for a time, and then when conditions are right, these cysts, as I mentioned, start to bloom. The other thing that could happen is it can travel on birds. You have mallard ducks go into a lake, they get spores on their feathers or on their feet, they fly to another lake. There's the introduction. So ballast water or bilge water from boats also a potential. I know they do a pretty good job of checking for that in Canyon Lake regarding mussel introduction. But there's always the chance that something got missed. So there's a few different vectors that could have happened there.
Okay, just wondered.
And that's all theory. I can't point to anything specific and say, yeah, that's it.
Yeah.
But these are some theories. So taking what I just showed you about the phosphorus and golden algae density, what we wanted to do is kind of run with that a little bit. And so we took some samples from Site 10 in East Bay, Site 8 in East Bay, and did a little kind of like just down and dirty pilot study to see what we could see. So what you see at the pictures of the flask there, two different sites, Site 10's on the left, Site 8's on the right. We took the same sample and we either added nutrients to it or we just left it alone. And so the flasks that are on the left of each group are the ones we did not add nutrients to. I'm sorry, yeah, we did not add nutrients to. The ones that are on the right of each one, the greener ones, we did add nutrients to those. And so starting on day 1 of the test, we also took these same samples and ran toxicity tests on them with the fathead minnow again. Site 10, at the start of the test, or day 0 of the test, high golden algae counts, very toxic. Site 8, low golden algae, non-toxic. Okay, it's not expected, right? We see that from what we've seen in the samples. However, following, along with site 10, which was the toxic site, when we added nutrients to this sample, actually, let me step back. When we start without nutrients, the sample we didn't add any nutrients to at all, the golden algae population stayed fairly high, and we saw a reduction in the other types of algae, the typical green algae you see in the lake. Those dropped out. Golden algae took over the sample, and it was still very, very toxic. The sample we added nutrients to, there was a shift in the community. The golden algae actually started to dissipate. The green algae took over. And you see a picture of what we saw in the sample there on the right-hand side. Katy Lake, after nutrient addition, the beneficial green algae started to take over, and the sample became non-toxic at that point. Presumably because the golden algae have reduced in their population. So what we're seeing in the
Question. Okay, so I want to make sure I understand, because this just kind of sounds in the reverse to me. So I just want to make sure I understand what you're saying. So without nutrients, fatheads were done. They died off because the toxins, but with nutrients, fatheads survived.
Fatheads survived. No toxicity. So that's what it says. It was non-toxic, 100% survival of the fathead minnows after 4 days of testing. Yeah. And so the sample that we did not add any nutrients to, the golden algae remained. The sample that we added nutrients to, the golden algae was still there, but at a much lower density. And we saw a blossom of green algae in the sample, and the sample became non-toxic. And this is something we've seen in the literature. As I mentioned, we've seen other studies report lakes with higher nutrient concentrations tend to have lower degrees of golden algae problems, even if they had them in the past. So again, a conundrum when we're dealing with the lake, we're trying to get rid of phosphorus in the lake, right?
That's a problem.
So this is my last slide, and then I'll transition over to Steve, where he's going to talk about some in-lake alternatives. In basically what we know about green algae, we know that it tends to do better in higher conductivity water, higher saline water, higher or mild temperature, somewhere between, say, 19 degrees Celsius and about 25 degrees Celsius is its sweet spot. If it gets higher than that or lower than that, you tend to see the growth rates go down. Lower nutrients, it tends to do better without as many nutrients in the water. This is both based on literature and just by our own small side scale study we did here in the laboratory. And as I mentioned earlier, the strain that we're seeing in golden algae appears to be unique from what we see in other studies in the literature. Is more tolerant of lower salinity water. In fact, it's probably the lowest salinity water that I've seen of any study out there. There might be some that I haven't seen yet, but of the ones I've looked at, that's the case. Plus, they're more tolerant of warmer temperatures. Typically in the literature, you start to see them disappear somewhere below 25 degrees. They stayed in Canyon Lake up until about 27 degrees last summer, till about, like I mentioned, July 31st was really when we saw no more algae without treatment. So the things that we really need to understand kind of moving forward is we saw this difference between the main basin and the East Basin. Why is that? Is it because of pH? Is it because of conductivity? Is it because of a temperature? Potentially is sediment resuspension that we're seeing, either wind-driven or boat-driven. We're not sure. It needs to be investigated. And then we also have this concern of when you have this sudden drop in phosphorus, whether it's by alum application, as we've seen historically. I mean, we've been doing alum application since 2013 and haven't had this issue. Like, why now? Right? So it goes back to your question about how did this get introduced? Maybe it was a recent introduction, potentially. But it appears as if a sudden drop in phosphorus is where we start to see the issues, increasing golden algae, increasing toxicity. So we're going to be proposing a few different studies to look at these various factors, looking at salinity, pH, and temperature, as well as nutrient introduction, to see how this affects, and do they interact with each other? Potentially you see a different result at a high pH and no nutrients, low pH nutrients. You might see some interacting factors here, and we want to know that, because this will inform how we move forward with the long-term treatment plan of Canyon Lake. Whether alum's the right thing, do we need to move on to something else? Which is what Steve is actually going to get to on the next set of slides here about in-lake treatment alternatives.
Pretty much saying the problem is in the fall, winter.
The golden algae prefer colder water, so that's when you typically see a bloom. Over the summer, it tends to dissipate.
But we do have some time for the next season. I mean, we're almost out of this.
Well, we're probably still in it for a few more months. Like last year, we didn't really see it disappear till around June 25th or so. So it depends all on the water temperature. Yeah. Like the collections we had last week, we're still seeing samples in East Bay up in the over 10,000 cells per mil just last week. So not as bad as last year.
Right, you have to find, this cannot go every year.
Right. Yeah.
And she's one that's angry. He was at 300 and 400 people.
It's great. You know, it's been nuts.
Yeah.
I was
So-
at the meeting back in June of last year. Yeah, there's a lot of angry residents.
And I
Um,
noticed it, but, second time around, I mean, Lake Elsinore has the best experience with it and trying to deal with it, but they didn't have it come back, right? It didn't come back.
Yeah, that's what was really interesting about that
But I
that
think,
biomass. Oh, sorry, go ahead.
but I think we've changed several things
Yeah.
in Lake Elsinore, including, you keep talking about phosphorus, and perhaps the disturbance,
Mhm.
right? The phos lock that we're using is creating a crust, if you will, across the bottom. It's taking the phosphorus out of the water column, and it's adhering it to the bottom of the lake. But I just heard you say that when that disappears is when the brown algae in Canyon Lake is appearing.
Yeah, it seems as if it's there since last April, it's really been there all the time, except for over the summer when the temperatures went up and then came back. When we're seeing the toxic events is when the nutrients get pulled out. So whether this is, okay, it's a stress response, my nutrients have been taken away, I'm going to emit a toxin or not. That's the crux of what we're trying to figure out.
So we've been doing three different things. One is the phos lock, and the other is the algicide treatments. Obviously, we have a larger body of water, costs a lot more money. But we've been doing that, I believe, 3 times a year now.
Yeah.
And then there is the nanobubbler system
Foliar units, yeah.
that we have installed, 3 different barges, and we're going to get another one. We have, and Jeremy and I have discussed this, offered that to the city, the POA. We have a portable one as well
Mhm.
that we used behind the 70-acre Summerlee Pond when we had some odor issues there 2 years ago. So that is available, just putting that in your toolbox. Obviously, nothing's free, but we would be willing to
Yeah.
rent that to, help the cause. So I think what we've been doing seems to be working, and I don't remember 200 tons of carp. No, we filled 1 bin, and that was it.
That number
So
sticks in my head.
it was 4 days of a slow kill. We scooped everything up, and there was no outrage because we had people on shore, county side and city side, cleaned it all up.
Mhm.
No smell, no mess. It all went to El Sobrante.
To the mayor's point, I was told that nanobubblers are actually a bad thing when it comes to copper. Is that true or not?
When it comes to copper?
Yeah, I'm sorry, when it comes to algae, golden algae.
Not necessarily. No. I guess in what way were they referring to?
It just that wouldn't be the proper way to try to treat it last year when we had the spike.
Well, I don't know. We haven't really tried treating golden algae with nanobubbles before, so I can't speak on that, I guess to say. I mean, we do know that it's done some good things for Lake Elsinore as far as bringing up the oxygen levels and suppressing nutrient flux from the sediments. I can't say specifically how it would interact with golden algae because I just don't have the experience with that.
Good to know.
Okay. Now, saying that gold or nanobubbles is on the list of treatment alternatives that we're looking at. Steve's going to be going through here in a minute, a list of 17 or more different types of treatments that could be implemented in Lake Elsinore or Lake Canyon Lake. Not specific to gold algae, but just for long-term management of the lake algal biomass in general, which includes golden algae. So, go ahead.
Before we lose you, Mr.
Okay.
Chairman, can I ask you some biology questions?
Sure.
We've seen the varieties of fish, so it wasn't just one type. It was across the spectrum. Were any turtles impacted at all, or waterfowl?
Not that I know of. We didn't see anything at Canyon Lake as far as, or any complaints regarding turtles or waterfowl at Canyon Lake. And in fact, I know, I mean, the golden algae toxin specifically works on gills. Obviously, turtles don't have gills, birds
Right.
don't either. So it's aquatic organisms that live in the water that have gills that are the issue. So like zooplankton, for example, could be susceptible to golden
Did-
algae toxin.
Did California Fish and Wildlife weigh in on this at all?
Not yet.
They-
No.
they-
They know about it. They know about it. It's
Because they historically love to come take samples at our lake 10 days before every holiday so that they can try to, close us down. It's such a great partner.
Yeah.
So they've not weighed in, they've not done anything. They're busy attacking private property owner rights.
Well, I can't say what they're doing
Okay.
specifically, but I know I haven't had any conversations with them about this specifically.
So
Yeah,
I know Lake Elsinore, under the Regional Conservation Authority, the water body is considered public, quasi-public, and part of the protected area under our massive habitat plan. Canyon Lake's the same thing,
Mhm.
right? Okay, so has the RCA weighed in on what's going on at Canyon Lake?
I haven't seen anything.
No,
on
they
that
haven't.
myself either.
Can they get through the gate?
No, that's the issue.
I know it,
That's how we get rid of the whole fishing game coming in too. Yeah.
but how did the algae get
Can't
in?
even get in the gate.
There's these pipes and these lines that we can't find, but we're trying. We're trying.
All right, sorry, I just wanted to
We're
be-
just not as extreme as you guys are when it comes to,
It's a good point.
your methodology. So,
Good point. We do have the high speed zone in the middle of the lake, so
yeah.
you're welcome to come test that. Thank you very
Yeah.
much.
Thank you for the
The other
presentation.
thing I just wanted to point out regarding Lake Elsinore, and maybe some of the differences of potentially why we're not seeing golden algae coming back at Canyon Lake, even though we know it was there in high concentrations, is that the algae population in Canyon Lake is much different than what we see in Lake Elsinore. The cyanobacterial counts, and even though they're not currently producing toxins, the cyanobacteria density counts are still there in Lake Elsinore compared to much lower densities of those same in Canyon Lake. There could be a population dynamic and competing interactions going on here that's suppressing the golden algae. I don't want to say that that's actually the case, but it's certainly a possibility.
The East Bay has
Yeah.
always been an issue,
Always.
just
Yeah.
always been an issue. And that's where the dredging started
Yep.
for the freaking 1 day or whatever it was before the lawsuit. That's always been, I guess we'll call it your Achilles.
Yes, 100%.
Thank you.
Did you have a question?
Yes, can we go back to the nutrient lab study?
Sure.
My question is, what type of nutrients are being introduced and what effects could they have on overall water quality for long term if you were to look at that as a solution, or what are we talking
not-
about for, the
Yeah.
need? How would you do a mass application like
Yeah,
that?
so I don't want to say that adding nutrients is going to be a solution to the lake,
Okay,
right? I mean, that's what we're trying to combat here. Now, the types of nutrients that were added to this specific study, it's a mixture that's used for, it's an EPA mixture that we use for various algal studies. And actually, algae is one of the toxicity test species that we use in other types of studies. And it's used to grow that algae. So it's just a generic mixture of micronutrients that are used to grow algae in general.
okay,
And so that's what was added here. It wasn't specifically, phosphorus or nitrogen, but
okay.
in general.
Okay, no, that's helpful because there was no, it's not a specific, so
Right.
is that, what we were looking for a potential long-term solution, or how does that even work, and what's the overall effects of the water quality once you do that? Because,
Right.
and,
Yeah,
unintended consequences, right? You
Mhm.
fix one
No.
problem and then you create another
Yeah, we don't
by
want
doing that.
we certainly don't want to create another. So that's why we want to do these studies, to try to find a balance. Okay, where do we need to be? Okay, we have golden algae now. We need to find the proper balance between,
Yeah,
shifting the equation too far that way or too far the other direction. And now we got cyanobacterial blooms in the lake. So,
okay, no, thank you.
yeah, well, let me turn it over to Steve real quick. We have a few
Okay.
more slides to get through, and he's going to go through some of the in-lake treatment alternatives for Canyon Lake.
Okay, so I'll just tell you when to switch the slide, John. And what you just said is the first bullet. Basically, the idea that we do not want to increase phosphorus and trigger blue-green algae blooms. We just completed a TMDL revision to set phosphorus levels and reductions in phosphorus to prevent blue-green algae blooms and harmful algae. to protect the lake from that algae. So now we have a predicament, and what we want to look for is other factors that we can also influence to control the golden algae while also reducing the phosphorus to improve water quality for and address both algae species. And hence the studies and the experiments to figure out what those other factors might be and then how we might implement that and extrapolate it for the lake. And so, ultimately we're looking to maintain beneficial uses, recreation, the fishery, but it's also a drinking water supply. So we need to think holistically. The TMDL revision provided another 20 years before we're hitting that interim milestone for compliance. And so that time is used to evaluate what we're doing currently and improve upon it so that we're ready to meet that interim milestone in 20 years. And then the reason you want to have a long-term strategy is to limit the amount of times we need to come in with emergency action like we have in this past year. And so if we can dial the lake water quality in using controls, we can avoid having to do algicide treatments on an emergency basis to deal with golden algae or blue-green algae for that matter. And so we'll go to the next slide, and I'm going to actually pass it off to Chris because this slide is all about experimenting with golden algae, which is what we're doing in the near term. And then I'll jump back in after that.
Okay, great. Can you all hear me okay?
Yeah.
Okay, perfect.
Chris, real quick for the team.
Yeah. Well, John did a great job already describing the rationale and what we're trying to understand. So I won't spend too much time here, but just that we're working to iron out the details on some experimental designs that we can pursue to really understand what the conditions are that this golden algae thrives under and what conditions we might want to try to avoid. And we're looking to start off with some single parameter laboratory tests. So that would be adjusting the pH or conductivity or temperature or nutrients just by themselves. And we're discussing doing this with a mixed culture from the lake and also a clean culture that we're going to just have a golden algae culture. So it's going to take some while to create that. Dave Karen at USC, we're working with him on some ideas there so that we can kind of see how any kind of treatment is going to react with the golden algae by itself, but also in a mixed culture. Once we get that information, and you'll see that bullet there to algae source assessment, we might want to try to get some samples from those golf courses up there at Menifee Lakes, just to see if there's an ongoing source that's potentially up there. Once we learn a little bit more about a single parameter and how that affects the golden algae, we are proposing to go into some combination type tests where we maybe tweak one or two of the parameters that make the biggest difference with regard to golden algae growth. And this is all going to help lead us to, again, the parameters that we want to try to avoid or maybe encourage to avoid golden algae blooms. And this third section here, the spore viability, we're probably going to have this as a back burner one for now, but it is that question, and John brought this up, as to whether or not disturbing the sediments at the surface is bringing these spores back up, and that's causing an ongoing source in the East Bay at this point in time. But I think we're going to learn a lot from round 1 and 2. And so we're just finishing the scope up right now to hopefully get these experiments up and running very soon. And I think that's all I have for this slide, but I'm glad to entertain any further questions.
Questions back up to you guys?
No? Okay.
So more on that in the future. Going back to long-term planning, we developed the TMDL. The primary objective is to reduce nutrients to levels that are protective of blue-green algae. And what we are currently doing is using twice per year alum additions to reduce phosphorus. We've seen chlorophyll A, which is a measure of general algae, not golden algae, come down. And to levels that meet the 2004 TMDL. The revised TMDL actually further reduces the amount of phosphorus, or requires an additional phosphorus reductions beyond what was required in the 2004 TMDL. And so one of the tasks in the implementation program is to look at in-lake treatment in Canyon Lake as well as Lake Elsinore, and evaluate whether what we're currently doing is sufficient or if we need to supplement it or change it altogether. And so that is what we're up against. And we have a list of 17 in-lake treatment alternatives that was designed by Dr. Alex Horn that are general for the nation. Some of them don't even apply to Canyon Lake or Lake Elsinore. And so we're starting with that list, and you'll see it in the next slide. And you see in the last bullet, we have some experiments that we want to do to better evaluate some of these alternatives. And some of those experiments involve cold algae. Let's go to the next slide, John. Okay, so this is our long list of things that we're looking at. It's sort of like we've been doing alum applications for 12 years. We had many, many years of no hiccups and good water quality. Now it just so happens with the timing of the TMDL and the golden algae blooms, we're coming back to this bigger picture of what are our various alternatives that we can do to improve water quality, reduce nutrients, and meet the TMDL. And we just completed this exact analysis for Lake Elsinore. And in that example, we said only one of these alternatives was viable, oxygenation. And I remember we did present that to this group about a year ago, maybe 2 years ago. And within oxygenation alternative, there are multiple options on how to go about doing that. And that's kind of the nature of what that long-term planning analysis involved. Here in Canyon Lake, we're dealing with a smaller lake, simply potentially more manageable, and maybe some of these alternatives beyond just oxygenation are actually quite viable. And so we're in the process of going through that process of saying, which of these should we evaluate further? And we mentioned dredging. Dredging's number one on the list. It was historically there was a dredging project, as you know. We are looking to evaluate that again, among many of these other ones. And I guess we will report back on the results of that screening analysis. That's just to say, what should we evaluate further? It's not to say which, how and what the costs are. We're taking a look at things in a very 30,000 foot level to say, does this have promise? And if so, then let's dig more deeply in, do the engineering analysis, do the effectiveness testing, and implement some of these special studies that we need to really understand things like, what kind of chemical addition is best, especially with regards to these other complex variables like golden algae. But there's two others that are on our mind. One is sedimentation. So the way we're applying alum now, the flock is settling to the lake bottom. One question that we think is timely to answer after 12 years is to look at the bathymetry of the lake and decide if the alum program has accelerated sedimentation or if it's, just basically in the noise of the watershed loads that are settling out. And we can look at that and answer that question with this time to do in this next study. And the other one is the one water perspective. This is a drinking water supply. And so we need to kind of always account for that in what we're recommending. And so there may be some nuances there too. You can go to the next slide, John.
The question?
Oh, yeah, question?
We got a question.
Couple of things. First, with the number one item being dredging, it absolutely does not make any sense unless A, there's a CEQA exemption, and then B, there's an identified disposal location that is economically viable. And that's where we have to rely on our state and federal partners. They need to be able to come to the table and help us address these issues, because why would we even spend a week looking into dredging?
Yeah.
Because we already know it doesn't work under the current rules and regulations that we're forced to abide by. So unless somebody knows how we can get this exempt under CEQA and identifies a location where we can dispose of this material, it's just a non-starter.
Steve, do you want to speak to that?
Sure. I mean, we will document that in the report. And then I guess, the cost and the complexity of that would be accounted for in any kind of rating or prioritization analysis. It's a long-term project, right? And so dredging may be many, many decades out. But many folks say, well, at some point, Canyon Lake may need to be dredged. And at that point, we'd probably have to jump through those hurdles. And the other,
We've been saying that for 40 years, which is older than me. So conversation that's been going on for a long time. And I think you had mentioned that this list is a national list of
Yeah.
suggestions. So I think this is a copy and paste scenario that they put together for us on ideas not to be taken seriously, even though the dredge one is number one.
Well, yeah.
I think this is just a copy and paste scenario on a national scale on things that we'll be looking at to try to address the situation. Is that
The numbers
correct?
you see here in no way represent
Of course
a
not.
ranking.
But I
So-
think that was noted earlier.
Yeah.
Yeah, and this is just the full spectrum, or close to it, of
Mhm.
options on the table. Some of them, like you said, are just maybe non-starters, right? And that's what the whole screening process is about, is to go through them. Some of them you don't even need to go down very far that road.
So a decade ago,
Yeah.
just the environmental document to dredge Lake Elsinore's inflow channel was $500,000. Just that portion of our lake, what is that, 20 acres out of 3,000? So again, it's a non-starter unless the law changes.
Okay.
One other thing, on the last bullet here, my colleague has pointed out that you've indicated no reclaimed water. Lake Elsinore enjoys 5 to 6 million gallons per day of reclaimed water. It helps us keep pace with evaporation. But there's also another element to that. The water district can't discharge every bit of water into the Temescal Creek. So they need an outlet, and that outlet is Lake Elsinore. So I guess I'd like to revisit why we put no reclaimed water there.
Steve, do you want to speak to that?
Yeah, I'd love to. Because I actually talked to the Water District today about indirect potable reuse in Canyon Lake, as a potential option. So no reclaimed water, I think, is the current existing condition. But the idea that we might use Canyon Lake, to put diluted water, that's option 8 on this list, is something that was evaluated in 2017 by the district this is when, for the flows that come in above what Lake Elsinore needs for stabilization, potentially that could be treated and then delivered to Canyon Lake, kind of like the Pure Water program in San Diego does. And so we're looking at that as an alternative. Obviously, it's a highly costed project, but the district is looking at indirect potable reuse down the road once flows reach that point in time where we're exceeding what Lake Elsinore needs.
Okay, but the process that you're talking about for Canyon Lake here, that infrastructure doesn't exist today, correct?
Correct.
Okay, thank you for
It would
answering.
be very expensive, yeah.
Any other questions? No. No? Okay, that was all the questions for that.
Okay.
Okay.
That's for Steve here. Yep.
Yeah, we have a slide on chemical inactivation because that's essentially what we're doing now. So we know we're going to be putting that forward past the screening analysis into let's evaluate it more closely. And as I said, each alternative has many options for how you can go about it. And so you could see the first line, we have routine low-dose surface applications of aluminum, and that is what we are currently doing in the active program. But there are many different ways, including we can do a single large dose of alum or aluminum, which will inactivate the sediment releases. And instead of the external loads coming in each year, that may be something that we would look at in the evaluation. And then other approaches can include dripping alum into the wet weather inflows as it enters the lake. This has been shown to be successful in many lakes throughout the nation. And we can look at what that might involve for Canyon Lake. And then lastly, there's an idea to take water out of perhaps the hypolimnion of the deepest part of the lake, and then recirculate that to the top ends and create a recirculation. And then that recirculating, adding a treatment train to add some alum. A costly option, but something that could really be beneficial. Let's go to the next slide. Okay, so in order for us to evaluate some of these things, we want to look at conducting some additional experiments. The first one, we talk about how much phosphorus is being removed for the amount of alum or other chemicals that we're adding to the water. We have a basis for that in our current program, and so we're taking that estimate and then estimating offset credits. These are reductions in phosphorus that we are assuming based on this ratio of the amount of chemical inactivant added to the amount of phosphorus removed. We want to update those experiments based on site-specific data and the water quality in this era. The second bullet talks about aluminum toxicity. And so if we wanted to increase the dose of aluminum or another chemical, we want to look at the toxicity of that. As you can see, we have a lot of experience running toxicity experiments. And so we can look at that. And then that could support future CEQA at higher doses or different doses. The third bullet talks about bathymetry, looking at how fast the lake is infilling. We have historical bathymetry, which is the storage of the lake. What is the bottom of the lake's depth and how fast is that rising? And so if we find that's rising faster than naturally would be, we can adjust our long-term strategy. And then lastly, and probably the most poignant, is the influence of golden algae. Is a new variable, but obviously it's a monkey wrench. I think somebody said monkey wrench the other day. I think that was fair. Let's go to the next slide. I think that this slide was in here just to remind ourselves that what we've been doing has been working really well. Chlorophyll A's come way down, Secchi depths are up, so we have more transparent lake. And here's the reductions in phosphorus that have been achieved. And we've been able to get the regional board to recognize the value of the alum addition program. It's been an extremely cost-efficient way to meet the 2004 TMDL. And so we don't want to forget that as we go forward. And actually, when you read the TMDL revision, under task 4 to evaluate the long-term plan, it also says, in the meantime, continue to add alum in the current plan. And so it doesn't say stop what you're doing and reevaluate. It says continue what you're doing and then also reevaluate. I don't know if I have any more slides, John. Oh, next steps. I don't remember this slide. We're certainly narrowing down the 17 in-lake treatment alternatives. We will take the comments on dredging very seriously here, and perhaps that is not going to be something we look at. Yeah, refined test methods. Yeah, the golden algae inference, obviously. We're working with SAPA on these really neat experiments that Chris talked about to understand that relationship. Other variables that we can tweak in addition to reducing phosphorus, but also maybe reducing salinity, pH, maybe changing the pace at which we drop the phosphorus. Like in the current, John, you mentioned this, like a gradual reduction in phosphorus may be much more, protective against triggering some sort of golden algae bloom out of the blue. And we're working with Task 4. There's the actual language to review and reauthorize the existing lake project, so the alum edition as we're doing it today, and approve new in-lake treatments and studies. And so I guess I'll take questions.
That was it. Yeah.
Do you?
It's a lot of information. Yeah.
No,
Yeah. well,
it's a lot of information, but I appreciate it because obviously this is something that's right in our face right now that we need to figure out and deal with it. So my first question, and I'm really glad that staff is here, and I'm really glad that Karen is here today. So when we're looking at cost, I'm going back to your slide with your anticipated or what your estimates are for cost for doing the various different levels of testing, which at the high end could be upwards of $200,000. So my question goes back to initially, and I think I asked this at the last meeting of Rick, to figure out, have we initially started all of this process many years ago, trying to get grant money and got funding for $600,000 initially in order to start all of the alum treatments to do all of these things. So one, have we identified any possibilities for bringing grant money in? Two, what are our available funds even to talk about at what level we want consultants to engage in that we can talk about at this point now? Because I don't want to put, I don't want to spend money out there we don't have either. So we need to identify a source and talk about what our available funding is at this point. I mean, not that we don't want to do the testing, because shoot, I could tell you, yeah, hit it, let's do it, but the reality is we've got to pay for it. Somebody's got to pay for it.
Yeah, within the task force, what we've done is we have budgeted monies for the fiscal year 26-27 to do this task 4, which was the alternatives analysis. We're going to have to and we're working with the regional board on presenting to them a proposal for a revised plan to move forward, slows things down to where instead of jumping directly into task 4, which we estimated to be about 200,000, we're
Okay.
going to use some of those funds initially to look at these water quality studies. So we're doing that. In addition, it's a combination of, we had very low phosphorus levels. And one thing just to point out, when the phosphorus is already very low, you get you don't get as an effective bang for the buck in applying alum. So alum is much more effective when the phosphorus levels are higher. But with postponing that, we're also going to go back to we're going to go back to you guys just to make sure we're okay to revise our budget to use the funds we had allocated for alum to use to do on, because that spring alum application, to reuse those funds for these studies and to help start us off on the alternatives analysis.
Okay.
So those are two funds. In addition, we are with Erica here, she's got some ideas for different grants that are more federally focused, water quality focused. So we're looking at some grant opportunities. And we're also going to be trying to take some of these studies that are a little bit longer down the road to try to see if we could hit, because grant, it takes 6 months to a year. So we have studies we have to do right away. We're going to try to use the TMDL. We have budgeted funds. We have funds that we've postponed with this spring alum application. And then for longer term studies, we're going to try to get into some grants.
Okay, got it. No, and that's helpful. I'm glad we're looking at a variety of different sources. But I think the other thing that we really need to probably have a little bit of a conversation about is the fact that we have several partners that are being affected by this. This isn't just this body trying to take this. So perhaps we need to talk about some money being kicked in from other sources, because ultimately this is going to benefit all those parties. And so we probably at some point should knock on the door of other agencies, the city, the POA, the water district, both cities, sorry, to talk about, hey, this really is a holistic problem, and we holistically need to try to figure out and solve it. And maybe the burden wouldn't be so bad if we can all kick a little bit of money in to try to figure out how to proceed with a solution and then ultimately, hopefully, deploy one, right? And try to solve our problem. So just kind of something that I want to plant to my colleagues here for a level of discussion and how they feel about that. I mean, none of us want to spend money that we didn't anticipate and budget for, obviously. But this is something that is kind of in our face and a lot of people are raising concerns about and needs to be addressed in a thoughtful way. So I just, and I'll leave my comment there.
Okay.
Thank you, Mr. Chairman. I appreciate my colleagues' comments about sharing the pain. I would just remind everyone sitting at this dais, when it came to the nano bubbler system, crickets, absolute crickets. I'll get off that and go to the money that we have on hand, the audit that we were just shared. $750,000 is cash on hand is what I saw, and I imagine that's what you'll be using to start as you begin this process. I want to come back one last time to my favorite partner, California Department of Fish and Wildlife. Now, when it comes to land development applications, they're always there with us, partnering, hacking, restricting, making sure that we are in full compliance with the multi-species habitat conservation plan. They come out and test our water. Their wardens, at least once a decade, come out and check for fishing licenses when they're not writing tickets to small children with dogs off leashes. But when it comes to the resources dying, a major fish kill of both invasive and native species, game fish, tons of game fish, where are they? Where are our partners? When we start looking at grants, they need to be part of the pond that we drain from because they should be helping us. And I'll get off that for now. Thank you.
Any comments from this side of the house? I haven't got to comments yet. We're still on this topic.
But
Anybody,
it sounds
anything
like
else?
you jumped right to it, so go ahead, nope.
Nope. I think we're done.